Hi everybody, welcome to our first live stream in a series we're calling Meet the Scientist. We're coming to you live from the Youth BIOlab at the Albertson Research Center at St. Boniface Hospital here in Winnipeg, Manitoba, in Treaty 1 territory, the traditional territory of the Anishinaabe people, Dene, Cree, Dakota and Dene, and the homeland of the Métis Nation here in Winnipeg. I'm Steve Jones. I run the Youth BIOlab here at the Albertson Research Center. And our job is sharing the work that we do here at St. Boniface Hospital in our labs and over in the hospital as well with everybody out there. This is a new weekly live stream we're starting. We're going to have conversations with people from around the research center every week so we can learn a little more about the work that goes on here at the research center and the hospital. But more importantly, we're going to learn a little more about the people who do that work and why they love what they do. We've got Angelica watching the chat over there, so if you have any questions, you can join us over there as well and fire some questions at us and our guests. Like we say, every week we're going to try and get someone new down here. We're going to start right at the top with the big boss of the Research Center here. Joining us today is Dr. Grant Pierce. He's the Executive Director of Research here at St. B. At the hospital. He oversees all the work that goes on here in the Research Center, and that also means he's my boss, so we're going to treat him real nice. Thanks so much for joining us, Grant. I just want to show a couple people as we're starting up. They can see us sitting in the lab here. We've distanced ourselves a little bit in current times, but show people a little bit about kind of where we are in the city here. We're at the St. Boniface Hospital in Winnipeg, Manitoba, and we're right in this building here over on the right-hand side of this image, the Albertson Research Center. This is where we spend our time. I get to bring kids into the lab all the time, and we're going to find out a little bit today about what you do. So this is Dr. Grant Pierce, and I'm going to throw this up here for us too, Grant. He comes with all these letters after his name. Dr. Grant Pierce, OM, PhD, FACC, on and on and on and on. He has a lot of titles. What does this mean?
Well, FACC, for example, means Friend of All Canadian Comedians.
Really what it means is he's done a lot of work. He does a lot of different things. He's won a lot of awards. He has his fingers in all kinds of different things here at the Research Center, here in the hospital, across Canada, and with scientists around the world. And we're going to dig down into that a little bit today together and find out, what a day in the life of Grant Pierce is about and all the things that you do.
You're going to learn about the nerds of science.
Yeah, well, that's how it goes. You've been executive director here for how long?
15 years now, and doing research here since it started in 1987, so 33 years, if my math is right. So I'm one of the originals here with many, there's a few others here that came at the same time.
Yeah, so our building here goes back more than 30 years now.
Yeah,
and you were one of the first scientists up there. You sit in your front office here, but you still have your lab running up there on the fourth floor of the Research Center here.
That's correct.
Right. So one of the original scientists, so you're also a professor with the University of Manitoba, right? So you're kind of part of the hospital, part of the university. How does that work?
So I'm a professor in the Rady Faculty of Health Sciences in the College of Medicine, Department of Physiology and Pathophysiology. So my responsibilities are like any other professor at the university, and we have to teach university students, do research, and do service for the community.
Yeah, and that's really important for people out there to think about. I think everyone's heard of a professor, and we might just think of a professor as being someone who's standing up in front of classes at a university somewhere teaching students. But there's a lot of other things that come as part of that job description. You're a researcher first and foremost. You have a lab upstairs. How many people do you work in your lab? Like, you've got a pretty big team working up there with you as well, right?
It's not that big. It's a good size. I'd say there's about 8 people working there. They have different responsibilities, different education behind them. We have technicians, we have graduate students at a PhD level, so they're working to get their doctorate degree. We have people who are already have their PhDs and they're postdoctoral fellows. We have people who are research associates who are a little bit more senior than that. So you've got a wide variety. In the summertime, we have undergraduate students who are either in the very senior part of high school. Most of them are already in university and undergraduate. So yeah, you got a wide range of people who work with us.
And so you kind of, and so you have you're a PhD scientist. You know, as most people who would run a lab here, they've gone through that whole process of high school into university, and then go on and do graduate work after that first degree, a master's degree, a PhD degree, some more training after that. How many years of school does it take to get to run your own lab? This is a question that everyone always, all the kids want to know out there.
So when I went to high school, there was grade 13. So I did grade 13 in it was in Ontario at that time. So I did grade 13, and then I went and did an undergraduate degree of 4 years, and then 2 years of a master's. I did my undergraduate at Lakehead University in Thunder Bay. Then I did my master's at Dalhousie University in Halifax, 2 years of a Master of Science degree, and then went to the University of Manitoba to do my PhD. That's another 4 years. And then before you get a job, you have to do a postdoctorate, so it's after your doctorate degree. So I went down to UCLA in Los Angeles for 3 more years, and then finally came back and got a job. My parents were very happy that I finally got a job, and I think at that time I was, I don't know, 33 years old, something like that.
Yeah, and then you got your job kind of running your own lab, and that, you know, there you're starting to kind of, you get to develop your own hypothesis and the things that your lab really wants to focus on. And it's kind of all those years of training get you to that point where you get finally choose, like, what are the things that I'm really interested in, and what do I want to devote our lab's efforts and energy for. Where did that lead you? Like, what does your lab do up there? What are your interests? Your scientific interests?
So you're exactly right. Up until you get your own laboratory as an assistant professor, you're doing work on somebody else's projects. I was fortunate during my PhD. It was with Dr. Niranjan Dalla. He had more of a relaxed, I think, directions within the laboratory. So you did have a fair amount of freedom to kind of do what you want, which was great for me. But once you get into your own laboratory, then you're off to the races, and it's up to you to decide what's your creativity, what are your
I think we actually
ideas.
have some pictures from back in that time. Does that guy look familiar there?
No, that's some strange person who's in there.
Yeah. So, you know, back in those days when you really got to start your own thing, like it's a huge path to get to where you are right now.
Yeah, I mean, for myself, I may have a bit of an odd path of why I get into research, and that is, I was a basketball player.
Yeah.
So I played ball for Lakehead University, and we played against the University of Manitoba and against University of Winnipeg and all those schools. And so I was interested at the end of that on why some people were better than others as athletes. So what makes you better than me? Why could you dunk over me and I couldn't? Why were you faster and better player? And part of it has to do with how the body works. And so when I did my master's, it was really in exercise physiology, trying to understand how the body works and what makes the muscles work, what makes everything work.
And that's really what physiology is all about, like how the body really works and how everything kind of works together to do the things that we do.
And exercise is how it works during an exercise situation. Well, I often say my transition then into a PhD, which was medical research, is actually, it sounds bizarre to go from exercise physiology into medical physiology, but it's really not a big jump, because in exercise, it's much like disease. You are putting a huge strain on your muscles, on your lungs, on your heart, sometimes on your brain.
Sure.
And so it's very similar to a disease situation. The only difference is that in a disease situation, that stress is on 24/7. Right. It's going all the time. Whereas in exercise, you get
Your blood
whatever it
pressure
is.
goes up and all those
Yeah,
things, but it goes back down.
Yeah,
right?
it goes. So you've got a rest period of 23 hours of the day, and that allows you to adapt and get stronger. Whereas with disease, it keeps on going. So it was an easy transition for me and an exciting transition.
Yeah, and that's kind of where you ended up with, as you started your own lab, like, what are we interested in? And
Right.
it's, you're part of, here at the Research Center, we've got 3 main research divisions. We've got our Institute of Cardiovascular Sciences, we've got our Division of Neurodegenerative Disorders that looks at more brain and neurological disorders, and we've got our Canadian Centre for Agri-Food Research in Health and Medicine. You've kind of got a little bit in both, like in the heart research, and you do a bit of foods research up there as well, like you kind of looking at some of how these things cross.
That's some of the fun of being in research, right?
Yeah.
You get to do whatever you want in different areas as long as you're productive. You can be creative. And so our research right now is looking at flaxseed. So we have a nutritional group looking at flaxseed and its effects on the heart and the vasculature and cardiovascular health. But we have another major program now looking at antibiotics. So we have developed new antibiotics. Right now, COVID is just the start of a first pandemic. There is one lurking right behind it, and that is resistant bacteria. So bacteria out there are getting more and more resistant to antibiotics that we have. And as that occurs, it's going to transform medicine as we know it. Because any invasive surgery that you have will not be possible if the bacteria are resistant, because you'll get infected and you'll die from infections. So it's becoming a major problem, such that we think the estimates right now are that by 2030, there will be more deaths from resistant bacteria than there are from cancer.
Wow.
So that's a major problem. So we're trying to find new drugs that will avoid the resistance that these bacteria are building up against our existing antibiotics. And so far, so good. So we have some exciting research in that. So those are 2 completely different areas, and that's part of the fun.
But that is the fun of it, and I think as academic researchers, we don't work here. We're not part of some big company trying to make new drugs or vaccines or all these things. But we're interested in how disease works, and you get to really follow those paths of interest and think about things that are important to you or important to society, and put your efforts into those things. Like, we can look ahead to the next big challenge, or we can look at the big challenges like heart disease that we have right now and cancer that we have right now.
Well, you can't find a new treatment, you can't find a new vaccine unless you know what is the cause of the disease, usually at a molecular level. It's impossible. It's like throwing a dart at a wall and hope you hit the disease. Well, you can't. It's very unusual that it works that way. So you've got to know how the disease occurs, and then you can design, all right, how do we stop it at that particular point?
Yeah, and the nice part about working in a building like this is like, our Institute of Cardiovascular Sciences is not just you. There's all kinds of other labs run by all kinds of different professors with all kinds of different students and technicians and all the people who really work together as a team. They might not study the exact same piece of the big heart disease puzzle, but we're all working on that huge problem together and slowly filling in those puzzle pieces as we go.
Yeah, we have about 35 principal investigators, professors, who have laboratories here. That means, just like me, I just gave you 2 projects that are in our lab, but normally you've got 3 or 4 going on. So if you've got 35 professors, you have over 100 projects that are ongoing in your laboratories on a variety of different things. Now, some of them may interact with this guy, and another one may interact with that. So you've got students running all over the place and learning all different techniques, learning different areas of research, and gaining new knowledge. Our research center is a bit unique because we have, as you said, different research groups. Some are in the nutritional area, some in heart, some in neural problems. And I think that's a huge advantage, because your training as a heart person may be different than my training in nutrition or whatever I'm in. And so we look at a problem a different way. And
Sure.
so you come in with different ideas and it's different excitement and different approaches. And that's when you make advances in a field, I think.
Yeah, and it's not just going on here in Manitoba. These are people all around the world trying to work on these same global problems, right?
Yeah, it's interesting. We compete and we collaborate at the same time.
Yeah.
So we're competing with everybody to find the answer for cancer or heart disease or whatever. But we're also collaborating with
Sure.
people all over the world. So yeah.
Sure. So I mean, you say you kind of came to where you're at by, through sport and through exercise physiology and want to understand how the body works. And I think a lot of the people in this building, like that's where we all ended up here, is that curiosity about how the body works and a fascination with, how you keep this thing going for 80, 90, maybe 100 years. Maybe some of the students watching today, maybe they're going to be living to 110 or 120, right? Like these are the things that interest all of us, and I think that's kind of why we're all here doing the things we're doing. Were you always interested in science, like since you were a little kid, or did it just kind of come about later in life? Like some people think, oh, I'm destined to be this and I'm destined to be that, but for some of us, these things change and grow as we do.
Yeah. Heck no, I hated science. I remember the worst Christmas gift I ever got was a chemistry set from my parents. I said, what are you giving me this for? This is like homework. So no, I was not very much into science as a young person, nor was I really even in undergrad. It started kind of, I guess, in undergrad. But I was more interested in the arts.
Yeah.
And after a while, I started to realize that in the arts, it's gray. There are no black and whites. There are no, this is absolutely the way it is, and this is absolutely the way it is. It's not like that. And so I got a little tired of that and was looking for something that is more
Sure.
black and white. And science, for the most part, is black and white. This enzyme works like this, and your heart works like this, and that's it. So I was looking for real answers, and science can provide the real answers.
Does it always provide the answers very easily?
Oh, I didn't say it was easy. I just said it provides answers.
Yeah, but you got to work at it, right? There's also
nothing,
work involved,
nothing
right?
comes easy.
Do we have a question over there, Angelica? I see Angelica waving her hand.
If you weren't a scientist, what would you be?
Unemployed? I don't know. Probably. I enjoy writing, so I'd probably get into some aspect of writing.
And I like that you said that earlier too, that like being creative is part of it. I think a lot of us growing up in school, you think of, when you're being creative, you think of art and writing and those sort of things, and we often don't think that science is a creative process, but it really is. And in my time here, I've been here 20 years too. In my time here, like that's something that I've really realized. And who makes the best scientists are actually the people who think creatively, who have that creative sense, and good writers, like people who can write and communicate the things that we learn and the things that we're interested in. It's a huge part of what we do.
Research is all about creativity. Who created that microscope?
Yeah.
Who made it as good as it is now? Who created the plastic here? Who created these, tape and everything else?
Sure.
This nice tap. I mean, research is about creativity. You see it all around you. You get in a car. Who created the car?
Yeah.
It's all about that.
Yeah, it's all some sort
Sure.
of process, and you can work that into your scientific process as you
Absolutely.
go too. So I mean, we said it's not easy being a scientist, and you've been at this a long time. What are some of your reflections on what's good about being a scientist? What are the things when you look back on your career? You're rounding up your term as executive director, and maybe get back and spend some time in the lab. When you look back on that career so far, and there's still lots left, what's been the good parts? What keeps you going? And then we can even talk about what's been the challenging parts of that too.
Yeah, so many times I'm asked by students, I'm thinking about a career in research. Should I get into research? Shouldn't I get into research? And I think it's important that they come in with their eyes wide open and they understand the negatives as well as the positives. And there's lots of negatives. So I'll start with the bad things about research.
And there's bad things in any job too, right? Like you could ask anybody, no matter how much they love their job. We don't want to discourage anyone out there. No matter how much you love your job, there's good and bad to everything. Right?
But that's why I'm a scientist, because
Sure.
there are jobs I don't want.
Yeah.
And it's the same with everything. Yes? Another question.
Another question. What discovery are you most hopeful to see one day from St. Boniface Hospital? Research.
I don't think there's one particular thing. I think it depends on the research you're in. Obviously, the cure to cancer, the cure to this, the cure to that, you'd like to have all those things, but are they realistic? They can be, but what you're looking for is advances in treatment that have an impact on human life. The advances can be small or they can be major. Obviously, what we would like is major advances. Will our antibiotics actually have an impact on multi-drug resistant bacteria? Yeah, that's what we want. That would have a major impact. And maybe I can answer it too by going back to your question on the negatives and the positives of a research career. So I'll go back to the negatives and eventually get to an answer on that question. One of the negatives, I think one of the things that people have some difficulties on coming into this is instant feedback. We have an instant feedback society, and research isn't like that.
Yeah, I'm watching for those likes and follows up there for my instant feedback.
And so, eureka moments are few and far between.
Sure.
It takes a lot of work, sometimes years, to produce advances in research that we want. Mm-hmm. So some people are not geared to that, and they're not patient and work hard to ultimately get that goal that's out there. So that's one thing. Different people have different personalities on that. You got to work hard. But again, I think that's like any other profession. If you really want to be good, you got to put some work into it. I remember when I first got into graduate work, I was going to do graduate work. My undergrad prof said to me, there are 3 keys to being successful in research. And I said, great, what are those 3 keys? And he said, you either have to be A, very smart, or B, you have to work very hard, or C, be very smart and work very hard. And so when I came in, I felt, okay, I'm not too sure on A, I'm not too sure how smart I am, but I know I can work hard. So you work hard, and I actually got a great feeling of reward working hard.
Sure.
And coming home, you're tired and you've made some advances, you made some neat discoveries and whatever. But if you don't want to work hard, you kind of get out of it what you put into it. Another potential disadvantage is you'll never be rich. Until I was 33 years old, I didn't get a job. So you start with a lot of debt, and you're in school for a long time. Whereas if I'd have got out of high school at 16, 17 years old and got a job, I'd be making money, I'd have a family, I'd be off to the races, and here I was, still in school. So again, it's a lot of time in school, a lot of time before you get a job and make a lot of money.
You still did have time to have a family and all those things along the way.
Yeah. Now, I'm saying you can't be a millionaire, but I'm going to get to the advantages, which are you can be a millionaire, but I'll get there. It can be stressful in the job of research, but I think like any job, every job has its stresses,
Sure.
So it can be. So those are some of the things that you have to be aware of when you're getting into a research job, the negatives. But the positives, I think, far outweigh the negatives. Particularly for me and my personality. In research, and when you're a grad student and getting into research, you do not have a punch card clock. You're not here at 8 o'clock and you don't leave at 3 o'clock. I would go crazy in a 9-to-5 job. That's just me. And many people have 9-to-5 jobs and they love 9-to-5 jobs. I'd rather have the ability to come in at 10 o'clock or the ability to leave at 10 o'clock.
Just for all our viewers out there, I'll let you know, I get here at like 7:30 in the morning, and Grant's car is always here by the time I get here, and it's normally there when I leave. He's still working hard.
Yeah, but you have flexibility
Sure.
all the time.
Yeah.
And
Because
when,
experiments don't work. Experiments don't run 9 to 5 either, right?
yeah, but you're the boss on your time.
Yeah.
I like that.
Sure.
So that's a huge advantage. And when it comes to having a family, you know, if you have a problem at home,
Yeah.
boom, you go home.
Yeah.
So I like that. Second major advantage is travel. Of course, right now with COVID, nobody's traveling anywhere. But during the course of my career, I've traveled all over the world. So, you know, I've seen the pyramids, I've seen King Tut's mask, I've been to Greece and seen the Parthenon.
And that's all part of scientists sharing with each other, right? Like you can
go
take
to-
the things that we've learned here and speak with other scientists around the world wherever you want.
You're going to meetings all over the world.
Yeah.
Australia, Machu Picchu we've seen, Great Wall of China, I don't know, London, Paris, you name it, we've been there. And, you know, sometimes your family comes with you. So they've seen some of the greatest sights in the world, and it's a tremendous advantage. And then following up on your comment, when you're traveling to these meetings, you're meeting people from all over the world. So I've got friends in Prague and Berlin and, you know, all over the place.
Yeah.
And that's a huge advantage
Oh,
too.
sure.
You're meeting different people, different cultures. You get a different perspective. I've been in India, all over India, and you get a different perspective on people who have different cultural beliefs, different economic backgrounds, poor people, rich people, you name it. So it gives you a perspective on life. It's fun to see things nobody else has seen. When we publish a paper, it has to be absolutely new. Nobody has seen that. Nobody has reported that. So I think that's a lot of fun. I think that's exciting.
Yeah, and that's something I say to students all the time. Like when people ask us, you know, what are the big discoveries you made? Our discoveries aren't necessarily always big. And often if you went home to your family at the end of the day and tried to explain the thing that you discovered, some of these things are so small. These pieces of these puzzles are so ridiculously small, but it's something that nobody ever knew before, right? Like it's something that you discovered, and it might not make sense to 99.9% of the people out there when you try and lay it out scientifically, but the idea that, hey, that's something that nobody knew before, and you and your team got to find that thing out and contribute it to what we as people know. Like that's the real magic of it.
Yeah, and a perfect example is what we're doing with the antibiotics. You know, Dr. Debroff working with us was looking on a little protein in little bacteria that nobody was interested in. And he and very few people were interested in that. But that turns out to be the target for our drugs that block that and then kill the bacteria, these bad bacteria. And so, yeah, you never know when some of these things are going to be quite important because they are building blocks that everybody builds on to eventually have an advance on people. So let me get back to other advantages, which I think are the key ones. Number one, I said you'll never be rich, but nowadays you can. Things have changed since when I started. If you get a patent, if you find a drug that has an impact on cancer, you can be a millionaire. You can be a multimillionaire now because you patent it, you create a spin-off company. I know people who've got large amounts of money from companies they've created, spun off, and you know, how was Pfizer created? Well, it was created by scientists who ultimately created Pfizer and Merck and all these companies. So you can do that. But the primary, I think, advantage of being a scientist is that you can impact more lives than in any other job I'm aware of. And you might not believe me, and you might say, well, wait a minute. A medical doctor influences people every day. And you're right. He'll see 1, 2, 20, 50 people in a day, and that doctor will have an impact on their lives
course.
because he will be treating a particular disease when they came in. But in research, if you find the cure to cancer, you will impact more lives than in any other job because you'll be influencing lives you will never see. You will never be able to, in your
Long
life,
after you're gone,
all
even.
these
Yeah.
people, you will influence lives generations past you. Look at Banting and Best and diabetes and finding insulin. They're long gone, but they are still influencing lives
Absolutely.
even to today.
Mhm.
So for me, that's exciting. But the other exciting part of that is the question beyond that. What stops you from doing that?
Right.
It's just you.
Yeah.
It's just you. If I want to find the cure to cancer, the only person that's stopping me is me. And again, that responsibility or that opportunity makes it exciting. So
Sure.
it's only in research that nobody can stop me from finding a cure to cancer, heart disease, antibiotic resistance. It's just my own hard work and whether I can get people around me who are really smart to help us out.
Yeah, and that's another thing. And it's not always the smart. Like we often say, oh, scientists all have to be smart. My experience here too is, you really have to be curious, right? Like it's just you need the most curious people, the people who want to know how things work, and the people who want to work together as a team to try and just move things forward. And sometimes you don't know what direction you're going in, but it's just that common goal of working and to understand how things work.
Yeah.
That goes all the way back to your exercise physiology, or how does it work, right?
Yeah, it's a very important comment that you made because I think high school students, for example, are under the impression that a scientist has to be extremely smart. And yeah, I mean, you've got to have some intellectual capacity, but you don't have to be this big nerd. I've seen people who are extremely smart, way smarter than I am, and some are successful in science and some are not.
Mm-hmm.
I've been trying for 35 years to figure out what is the key to help you make discoveries. I don't know what the answer is, to be honest, but I think maybe that what that undergrad prof told me years ago. You got to work hard, you got to be smart, and you got to work hard and smart. But working hard to me is by far the most important component. You got to be interested, and you got to want to help people out.
Yeah, and that probably goes. I mean, for all our students out there, or people watching. I mean, that goes for any job, right? Like it's
absolutely. You got to have a passion.
Yeah, have a passion for it.
You got to have a passion for it. I mean, look at you as a teacher here. The reason why you're so outstanding is because you have a passion for teaching students, and it comes across. It comes across to the students, and then they get excited. So it's infectious. And, it's great.
Yep, and that passion. I mean, that we see that all the time here at the research center, and it comes down from your office, and it comes. You could walk to any lab in this building and see that same passion and moving forward and learning new things. And anyone out there who's watching, like I think that's all you can say is just keep learning, right? Like keep being curious and keep learning and find that passion somewhere along the path.
It's got to be fun.
Yeah. I think that's a great place to end it. So we'll thank Dr. Grant Pierce, Executive Director of Research here at St. Boniface. I'll check and see if there's any last questions in the chat over there. Angelica, thanks for joining us, everybody. We hope to be back here next week on Thursday, and we might have someone from our neurodegenerative disorders group come to join us and talk a little bit about Alzheimer's and brain injury. And hopefully you can tune into that. You can